It's sort of a response video to conference report partly, and partly draft science stuff. Anyway, physics or something like physics anyway. This camera could work a little better. Yeah, anyway. Alright, conference report made a video on Blip anyway, talking about the relationship, that value is basically a product of relationship. And he was sort of doing it in the way that like a progression, like relative to certain things. Position A is different than position C, D, E, or even plus or minus numbers. I think the bottom line is that the relationship that value has it's a relationship to attraction and repulsion. That's the basic game of physics here, is that there's attractive forces or feelings and repulsive feelings. Feelings that are good would be the attractive ones, negative feelings the repulsive ones, and they give things that character of being attractive or being repulsive. But the game is basically attraction and repulsion, and that's where this sense of positive and negative comes from. And the way that negative is created is through this repulsive feeling, this unpleasant, negative, repulsive feeling. The positive feeling gets a little bit complicated because, as I do argue often, I believe the positive is essentially made out of creating a false neutral that's somewhere on the repulsive scale, so that we do that relative thing. So now all of a sudden there are things more repulsive than our current state, and things less repulsive than our current state, and those are the ones we derive pleasure from. So that our pleasure sensations are basically created by satisfying a negative feeling, satisfying a deprivation or a harm that we can be aware of or not aware of. Tensions, anxieties, tensions, use the word twice, aggravations that we store, and that those aggravations can be relieved, and when those aggravations are taken away, we end up feeling good. And that's sort of the game. So it's the addictive psychology, which is you're not getting a real pleasure, especially when you're far into the addiction. You're just getting back to a neutral by alleviating the negative sensation of the deprivation, the repulsion of the deprivation. And so to bend that towards physics, yeah, physics is just this basic, on-off kind of thing. If something goes or something doesn't go. So we break it down to this quantum stuff. Yeah, I'm going to argue that the speed of light is not a speed phenomenon. It's a clock speed phenomenon. Just like in a computer, it's only on the clock speed that the quantum moves, the smallest particle. So it only has a change in position on the clock speed, and that change of position ends up appearing to us like speed, like movement, because it's this incredibly fast frame rate. So just like your computer is basically turning on and off all the time, you don't see it because it's doing it so quickly, 3 gigahertz a second. I mean, incredibly quickly. So you can't be aware of any of that. But it's doing stuff. It's processing all the time, and the universe is processing all the time. Incredibly fast clock speed, and on that clock tick is when the movement happens. That solves all the relativity issues in the sense that now we understand why there's no momentum, why light can acquire no increase in speed, and I would argue that there's no such thing as a decrease in speed either. All you can do is change the distance that something has to travel. So, for example, an electron will travel from point A to point B at the speed of light. Now, if I put it through a wire of a given conductivity, that speed will decrease a little. Well, it's not because the electrons are moving slower. It's because they're moving in a more convoluted path. They're ricocheting, and they're looping and being distorted because of the density of the matter they're traveling through. Even though all matter is mostly empty space, when you put a whole bunch of it together, the empty space adds up, and the matter is going to interfere with the electron, and the electron isn't going to be able to get from point A to point B unmolested. So it's no longer going to travel at what appears to be the speed of light. It still is. It's just traveling a much longer path to get from point A to point B. So I'm basically arguing that all movement on an atomic level is speed of light movement. There's no other kind of movement. And we're just seeing the manifestations in very complex systems of a lot of energy moving at the speed of light. So the question becomes, though, is this, I had different thoughts about how atoms function and how they capture, say, a photon, this thing moving at the speed of light. I would speculate that maybe this thing moving at the speed of light is captured by an atom, and it's caught in a gravitational, a neutral gravity, where it's maintained its speed of light character, and it's just trapped now in a circular path around a nucleus made of the other things I have to account for eventually somehow, neutrons and protons and neutrons. I said neutrons. Yeah. And so I have to account for that, the nucleus. But I was thinking of different ways of how we perceive what's taking place. So if I'm just saying, I'll go back to my school of fish analogy because I think it makes sense. I think that an electron is essentially a bunch of photons arranged in a school, arranged in some kind of mechanism, shape, okay? And it's through that storage of many photons, that's where it has the capacity to take on a new photon or release another photon. So it can take on a photon of one specific energy level and release a photon of another energy level, because it's a school and it has a balance in the end of how it's configured. The configuration is distorted if it's full and you put new stuff in. It's going to have to release something, and what gets released has to do with how the configuration is. So maybe all the small bits are in the center and the fat bits are on the outside. So then when a new small bit goes in, it would take two small bits going in for one big bit to be released. That kind of math might be applicable. But there's so many ways to try to understand how this takes place. But the bottom line is that I like the idea of dominoes flipping to describe that that's what a photon is. It's either it just leaps a full leap in space at a time, but obviously that's two-dimensional, and so realistically, the little quantum photon thing can jump in any direction. It can move in any direction, so it's basically just going from a place to another place in that distance space, and which way it goes depends probably on some force of either attraction or repulsion. So we're back to that game again. That's really the whole foundation of the universe, is attraction and repulsion. That's controlling all this energy, that all of it is being pushed or pulled by some function of its hardware, and trying to understand that hardware is the tricky part. So yeah, I'm still stuck. I mean, I had ideas about atoms and even the length of photons, and I was thinking in terms of like spaghetti. If I took a piece of spaghetti and I had it like a spool of it, and I could just shoot a piece of spaghetti into space from like the moon, and I knew exactly where to shoot it, what trajectory, so it would get captured in the Earth's orbit and then just start circling the Earth. How much spaghetti would it take to finally create what would basically be a moving piece of spaghetti, but it would be it would cover the entire atmosphere. It would create a sphere of spaghetti. Assuming that like the spaghetti that's on its path going around the Earth, that the tail end has to go next to it, and then the next one goes next to that, and the next one goes next to that, and that it can't get thicker, it can only get wider with each spooling. I just wonder how long a piece of spaghetti first you'd need to cover the entire, to create a shell around the Earth. That sort of relates to atoms having, there's all this stuff about, whether the electron is an up or a down, and, I don't know all of that physics. But I do know that it has to do with what position it's in, the electron orbit position, and that when that changes, photons get released, and that sort of just makes sense in terms of the fact that I'm describing an electron as being a mass of energy, and one electron would equal a million photons or some other kind of number. You just make one up because I can't do the math. But that there's how to put it? Yeah, so again, we're just back to that argument that there's a mechanism and in the structure itself. And so when you add a new piece in, when something new hits it, something different will pop out of it at a different place to retain the balance in the end. And the balance will have to be in some kind of narrow scheme of balance. But anyway, that would explain that up-down electron crap and the photon getting released at certain periods, and takes out all that randomness crap that people try to invent. So there's a lot of good to this as a foundation for understanding it. So, I mean, but the major thing is the clock speed idea, because that just takes away all the momentum. A photon can't have momentum in terms of nothing can give it momentum if a photon only moves when the universe is frozen on that clock tick, and everything is just in its position and it has no movement, and then the photon moves, and that's it. And so only when those things move does the universe have activity in it. So no momentum could ever be incurred or imposed upon a photon. Yeah. So the question it raises is this relative speed thing still, in the sense that if there is captured energy inside an atom, captured photons moving at the speed of light, and they're moving in front, I move some atoms in front of me, what's happening to those relative motions then? Because they're still moving, they're still only doing one movement at a time, but they're being caused to move in two directions at the same time. So they're moving like, one place in the A direction and one place in the C direction, or some other kind of, directionality. So, but they can't really do a diagonal, because that would be a longer distance. But they are able to be shifted in two directions at once without changing their speed, without incurring any change in speed from the perspective of the observer. They're still moving on this axis, they're just doing it this way. They're moving on these different axes without any degrading of their they don't have mass, but I mean no degrading of their approximate energy in one direction. Moving in other directions doesn't change their energy in the primary direction that we're observing, I guess is the point I'm making. Alright, that's probably enough. So yeah, I still got to figure this part out, but yeah, clock speed, it works. The idea of a clock speed works, in my opinion. That's how it should be understood, that the universe is yeah, it's running on a clock speed. Okay, there's no speed of light, there's clock speed. Alright, till next time.